Hello everyone, I'm here to help you with some codominance and incomplete dominance problems. First, I want to apologize that I forgot my stylus, so I hope you can read my handwriting. So starting, there are a few definitions you need to do on your own that can come from your notes or the paragraph up above. I just want to talk real quick about these bottom two words, hybrid. You should know by now that hybrid means heterozygous, and purebred, we're talking homozygous. I expect you to have those words completely spelled out though. So heterozygous and homozygous. You'll need to know that to answer some questions moving forward. So snapdragons are incompletely dominant for color. And remember, we learned that incomplete dominance means that snapdragons, in this case, their phenotypes can be red, pink, or white. So they're a blend or a mixture. Pink is a mixture of red and white. So first thing we're going to do is look at the genotypes. So the genotypes for a red snapdragon, they tell me to use R's. So red snapdragon would be RR. A white snapdragon would be WW. And a pink snapdragon, a blend of the two, would be RW. Okay, so let's do one problem here together. If I blend a red and a white snapdragon, remember I keep each parent on the side, then all of my children will be pink. So I have, for a genotypic ratio, 0 RR, 4 RW, 0 WW. My phenotypic ratio, I have no red, 4 pink, no white. And they should go in the order, when you're writing your ratio for these problems, it should go in the order of the genotypes we listed. This should be your first blank, second blank, third blank. Sorry, third blank. So remember that to fill them in the order. So you should go ahead and work all the problems on this page and all the way until number 6, and I'll give you a little help with number 6 if you are struggling. Okay, so for number 6, we see that this is still an incomplete dominance problem. There's yellow and gray. Those aren't spots, they're not stripes, we're not dealing with codominance. However, the homozygous dominant genotype causes these mice to die before birth, which is weird, but all right, let's go with it. So if looking at problem B, if I mate a gray mouse, so I look up at my problem, gray is GG, a gray mouse with a yellow mouse is YG. Again, I got that from the problem, gray and yellow. What percent of their offspring would die at birth? Ooh. All right, so Y is going to go first in my box because it goes first in my problem. And I fill out my Punnett square. And it tells me that it takes YY to die before birth. Well, none of these are YY, so it's 0% would die before birth. But I don't count the 0% unless you do the Punnett square. So make sure you have filled out Punnett squares on everything, okay? Okay, so on page 3, we're on codominance, and I want you to look at some blood type problems. Now, if you notice at the part I highlighted, the blood phenotypes O, AB, A, and B have some different genotypes. And these genotypes are written a little bit differently than you may have seen before. So instead of writing O as OO, they wrote it as 2 I's, lowercase, and lowercase to show it's recessive. A and B, they wrote as a capital I with either a superscript A, superscript B. So that's just a way to show dominant and recessive. It's okay if you know that type A blood can be written as AA or AO. If that's how you've been writing it, that's okay. Just understand, each of these go with the notation below them, okay? So this these two are going together. So let's look at a couple genotypes based on the notations written on this paper. You're homozygous for the B allele. You would have a capital I. Okay, you're dominant, and you're homozygous for the B allele, so it would be I superscript B, I superscript B. Okay, you're type O, you would be recessive. You can have your blood donated to anybody, universal donor, right? Donate to anybody. Blood type O, it's II. Okay, make sure you fill in all of those before we do some Punnett square problems together. All right, so let's talk about Brad Pitt and Angelina Jolie. Brad Pitt is homozygous for the type B allele, and Angelina Jolie is type O. What are the possible blood types of their baby? Okay, so I'm going to write this both ways. He is either B, and she is OO. Or if we write the new notation that we just learned, he is IB, and she is lowercase I, lowercase I. Okay, either way, we're going to get the same answer. Their children, when I fill in this Punnett square, which I'm not because, again, I don't have my stylus and I don't think I can write in those smaller boxes. All of their children are BO, or if you write it according to the new notation, they are IB, lowercase I. Either one of those answers is correct. All of their children should be that. Okay, now let's look at problem number 5. So, 2 parents think their baby was switched at the hospital. It's 1968. We can't do DNA fingerprinting. Mom has type O blood. That's the recessive trait. So we know that the mom has to be type O blood. I'm going to go ahead and write it to the old notation since it's hard for me to do superscripts and make everything fit. She has to be type O blood, OO. Dad is type AB. So his genotype is simply AB. Now, the baby has type B blood, so there's 2 possibilities. The baby could either be BB or the baby could be BO. Those are the 2 possibilities for the baby's genotype. Okay? Now, some of the really advanced of you might realize, hey, one of those genotypes doesn't make sense. We're going to prove that with the Punnett square. Okay? So we're going to do a Punnett square looking at the possible genotypes for these children. We have mom, we have dad. Okay? So all of the kids should either be type A, AO, or type B, BO. So do we think that this baby was switched at birth? I mean, no, probably not. Just because type BO is a possibility from those 2 parents. Okay? Now, again, obviously DNA fingerprinting is much better choice than blood typing, but according to the blood type, it's possible. Hopefully we're not talking, dad's a red crown and mom's a blue crown and the baby's a green crown. In that case, no, it wouldn't be possible. But in this case, sure, it's likely. Okay, and I want to help you with one last question. I want to talk about number 7. So number 7, we have mom, we have a baby, they have blood types, and then mom's not really sure who the baby daddy is, but she knows their blood type. She's trying not to pay for a DNA test, so we're going to at least try and eliminate some people, save her a little bit of money, okay? So mom is type A blood, right? That means she has to have the genotype AA or AO. The baby is type B blood, so the baby has to be BB or B-O. Now, if we're really honest, the baby can't really be B-B because it would have had to get one of those from mom, and it can't get that from mom. Okay? Mom probably has to be A-O to give an O to the baby, right? So who can we eliminate, right? By process of elimination, we can definitely eliminate Sammy the player, okay? And we are proving that with a Punnett square, right? Mom's A-O, Sammy's O-O. It's going to give us an A baby or an O baby, okay? Can't be the father. Right? Can't be the father. We could also eliminate the waiter because the waiter is type A. So I'm going to do the waiter off to the side here. The waiter, let's even just say he's AO. So if the waiter's AO and mom's AO, then the baby should be A or O. So we know we can get rid of Sammy the player, we can get rid of the waiter. She either slept with George the Sleaze or the cable guy. Make sure you put what I've just said into an actual sentence and you have at least 2 Punnett squares proving this. And you're going to do kind of the same thing on number 8. Who can you eliminate? You're just trying to eliminate. I hope all this helped you with your work, and you have a great day.